Imagine a coffee mug slipping from your hands, shattering into pieces on the floor. Watch those pieces carefully. They will never leap off the floor, reassemble themselves, and jump back into your palm. Why? After 43 years studying physics, I can tell you the answer is far stranger than you imagine. I'm Douglas Whitfield, and I've spent 4 decades obsessed with time's arrow, why the universe insists on moving in only one direction. Understanding this changes everything about how you see reality. Let me take you back to 3 in the morning in my Princeton office, 1987. I was watching footage of eggs dropping and breaking, then playing the video in reverse. My wife found me at dawn, surrounded by broken shells, the smell of raw yolk heavy in the air, muttering about entropy. But here's what kept me awake. When you watch an egg unbreak itself, your brain immediately recognizes something fundamentally, cosmically wrong. Here's the paradox that haunts physicists. Every fundamental law of physics, Newton's mechanics, Maxwell's electromagnetism, Einstein's relativity, is time reversible. Film 2 billiard balls colliding and play it backwards. Both directions look perfectly reasonable. The equations don't care which way time flows, yet your life has an undeniable direction. You remember yesterday, not tomorrow. Eggs break, coffee cools, bodies age. You've never seen smoke gather back into a candle or watched ripples in a pond converge to produce the stone that caused them. This isn't philosophical speculation. Without time's arrow, memory couldn't exist. Cause and effect would be meaningless. The fact that I remember my daughter Sarah at 7 but can't remember her at 57 isn't just biology. It's woven into reality's fabric. So where does this arrow come from? The answer hides in plain sight. Entropy. Before you glaze over, entropy is simply a measure of disorder, how many ways you can arrange something's components while it still looks basically the same. Watch ice melt in water. The ice is ordered, molecules locked in crystalline perfection. Once melted, those molecules scatter randomly through the glass. There are billions of ways to arrange melted water molecules. There's essentially one way to arrange them as a perfect ice cube. The universe doesn't prefer chaos because it's better. There are simply more ways to be chaotic than organized. Take a deck of cards arranged perfectly. Ace through king, all 4 suits in order. Shuffle once. The odds it remains ordered? Astronomically small. The deck naturally moves toward disorder because there are 52 factorial possible arrangements, a number with 67 zeros, and only one is perfect order. Ludwig Boltzmann figured this out in the 1870s. This brilliant, troubled physicist proved mathematically that systems naturally evolve from low entropy to high entropy. That's the second law of thermodynamics. In an isolated system, entropy always increases. That increase defines time's arrow. I can demonstrate this right now. There are 10 to the 70th power ways to arrange the atoms in this room. Of all those arrangements, only an infinitesimally small fraction would look like an organized space with a professor addressing a camera. The vast majority would be complete chaos, atoms scattered randomly, no structure, no life. Our existence proves we're in an incredibly improbable, low-entropy state, and we're sliding, always sliding, toward disorder. Here's where it gets wild. If entropy always increases, the universe must have started in an extraordinarily ordered state. The Big Bang wasn't just the beginning of space and time, it was the beginning of the universe in a spectacularly special, low-entropy configuration. Consider the cosmic microwave background radiation, the afterglow of the Big Bang still visible today. It has a temperature of 2.7 Kelvin everywhere we look. Everywhere, to within 1 part in 100,000, it's uniform. That uniformity requires incredibly precise initial conditions. Roger Penrose calculated the odds of our universe starting in such a low-entropy state. The number 1 in 10 to the power of 10 to the power of 123. Let me contextualize that. There are only 10 to the 80th atoms in the observable universe. Penrose's number has more zeros than there are atoms to write it with. After 4 decades, that number still gives me chills. The universe shouldn't exist this way, yet here we are. So the real mystery isn't why entropy increases. That's just mathematics and probability. The real mystery is why the universe began with such impossibly low entropy. In 1994, I thought we'd found an exception. My graduate student Michael Chen and I spent 3 years studying exotic particles called kaons, which exist for fractions of a second. We were investigating a tiny asymmetry in how certain particles decay, a preference for one direction of time. I remember the day we confirmed it in our lab. The instruments hummed in the darkness, screens glowing green with data. I thought we'd cracked the code, but we hadn't. The asymmetry was real, but nowhere near strong enough to explain the macroscopic arrow of time we experience. A fascinating dead end that taught us about particle physics, but not about time itself. Some colleagues think consciousness plays a role. Memory only works forward. You can't remember the future. And there's a thermodynamic cost to forming memories. Information and entropy are connected. Memory and time are linked. I'm skeptical, but I've learned never to say impossible in physics. At 73, I feel time's arrow in my bones, in my joints, in how memories accumulate behind me while the future shrinks ahead. But consider this. Time might flow backward in distant parts of the multiverse. Physicists have proposed that our universe might be one bubble in an eternal cosmos, and some bubbles might have time flowing opposite to ours. To their inhabitants, their time flows forward from their perspective. Compared to us, though, they're living in reverse. We have no way to test this. Maybe we never will. This is physics at the edge where certainty dissolves into wonder. After 40 years of research, here's what I know. We understand how time's arrow works. Entropy increases because there are more ways to be disordered than ordered. But we don't know why the universe started in such a special, low-entropy state. Maybe it's the anthropic principle. We exist to ask the question because we're in a universe where time flows this way. Maybe it's cyclical and our Big Bang was the end of a previous universe. Maybe it's simply a brute fact with no deeper explanation. I turned 73 last month. My granddaughter baked me a cake. Watching her grow from infant to bright, curious 8-year-old makes this research feel urgent in ways it didn't at 30. Every moment with her feels precious precisely because time flows forward. We can't revisit the past. We can only remember it. And that makes memory sacred. That broken mug will never spontaneously reassemble, but imagine if you could glue it back together. Not perfectly, you'd see the cracks. But you could use energy, intention, and effort to create local order, to decrease entropy in that small system by increasing it elsewhere, in your body, in the food you metabolized for energy. That's how life fights entropy, not by reversing it, but by creating islands of order in an ocean of chaos. I tell my students on day 1, the best part of physics isn't the answers, it's learning to love the right questions. We may never know why the Big Bang had low entropy, but every day young scientists push at the edges, studying quantum gravity, black hole thermodynamics, the fundamental structure of space-time. Next time you break something and can't unbreak it, remember you're witnessing one of the universe's deepest mysteries. Time moves forward because the cosmos started in an impossibly special state 13.8 billion years ago. Why? That's what keeps me coming to the office. Even at 73, I'm still chasing that answer. And that mug, cracked but held together in your imagination, reminds me that meaning doesn't come from perfect order. It comes from the fact that we're here at all, improbable witnesses to an arrow that began before memory, before stars, before anything. That we get to ask why at all. That's the miracle.